Okay, hello, hello, hello. I think now I am audible. Okay, now I think, wait a second. Yes, now tell if I am audible. Yes, I think I am audible now. Okay, great. So I was just telling that till yesterday, till now we have covered precipitation. After precipitation, we have discussed losses takes place. After losses, sir, you have told me that after losses, sir, runoff, whatever water is left off is takes place. That water runs off basically over the land, subsurface flow, then groundwater base flow is there. And after runoff, you will see that all the water through network of streams will join. Through network of streams will join your stream. Okay, and hence it will become a part of a stream flow. So ultimately, whatever water is there whatever water is left after the rainfall, after abstraction, whatever water is left will ultimately become a part of a stream flow. So now in this chapter, we are ultimately going to measure stream flow. We have covered this chapter, we have covered this chapter, and we have covered this chapter in the last class. Okay, so today we are going to discuss this. I hope this is very, very clear now. And in runoff, yesterday we have discussed what runoff is, what is direct runoff, what is base flow, okay, what is delayed flow. So we have discussed everything, okay, types of streams, perennial stream, intermittent stream, ephemeral stream, what is flow duration curve, all these things we have discussed. Now today we are going to discuss stream flow. Okay, one small topic was left, flow mass curve. We'll discuss that and the remaining things. Okay, so basically in today's class, what we are going to discuss is basically in today's class we are going to discuss flow mass curve. We will discuss measurement of stage. We'll discuss measurement of velocity. Obviously, you should understand. Let us say we have a stream. Okay, let us say we have a flowing water stream. What things can you measure? What things can you measure, sir? Obviously, I will measure the depth. Okay, I will measure the depth. I will measure the velocity of water. Okay, why? I will answer that also, why we are going to measure it, and I will measure the discharge. Okay, see, we have different kinds of streams. Some are turbulent, some are sluggish. Okay, so some are very fast moving. So based on that, we have different methods of discharge. Okay, so we'll discuss the conditions also, like which method is used when, that also we'll discuss. So we'll start a lecture today. Okay, so I hope everything is very, very clear to you. Wait a second. Now we'll begin with the very first topic, which is none other than flow mass curve. Okay, we'll discuss with flow mass curve and then we'll move ahead with the stream flow. Okay, wait a second. So we have to discuss flow mass curve first. Yes. So what exactly flow mass curve is? Okay, what exactly flow mass curve is? Okay, its red heading is already there. So what exactly flow mass curve is? Let me tell you. See, you all have understood about the hydrograph thing. Okay, you all have understood about hydrograph. I hope you all know it. Okay, I hope you know what hydrograph exactly is. Hydrograph is discharge versus time graph of a stream or of a river. Okay, yes sir, this is very, very clear. This is perfectly clear. Listen very carefully. So this is your discharge versus time graph. Okay, this is discharge versus time graph of any stream. Okay sir. Now see this graph, obviously in this discharge will vary. Obviously the river, or let us say any stream, will not have certain fixed quantity of water. Okay, obviously it will vary, it will move up, it will come down. Okay, so we have variations in this. So if I will plot hydrograph or discharge versus time graph, then what I will observe that this graph will go up. Okay, sometimes it will come down. Okay, sometimes again it will go up. Like this, you will have certain variations like this. Okay, so obviously this discharge versus time graph will vary. Okay, discharge will never be fixed. Sometimes it will more, sometimes it will less. It will like this. So this is your hydrograph. Now what is the meaning of flow mass curve? Let me tell you the meaning, but before that let me ask you one question. Tell me what is the meaning of mass curve. See, I have told you this thing. I have told you what is mass curve, so it's required by you all to answer me what mass curve is. Okay, everyone kindly tell me what mass curve is. I have already told you what mass curve is. See, mass curve was, you tell me, what was mass curve? Mass curve was, tell me, mass curve is none other than cumulative precipitation versus time. So here we will also do cumulative value. Okay, here we will also do cumulative value. So see what you have to understand here. See, it is a plot of cumulative value. See, mass curve will be, you need to understand here, see, this is the area, this is the area. Let us divide it into certain parts. Okay, let us say the area 1 is having area, let us say 1, let us say second area is having area of 3, fifth area, third area is having, let us say, area of 6, let us say fourth area is having an area of, let us say, 8, like this. Okay, now what I will do, I will do the cumulative sum. So cumulative sum will be 1, then cumulative sum will be 1 and 3, 4. Up to this point, what will the total area? 136 will be, 136 will be what? 136 will be, this is your 10. Then when you sum it up, you will get 18. Okay, so this is cumulative value, this is mass curve, and this is the normal value. Yes or no? Yes or no? Yes, cumulative involves time. This is perfect. Now, if I will plot these values, if I will plot these cumulative values, then you will see, then you will see, if I will plot these values, wait a second, 1, 4, I have to remove this. Yes, so 1, 3, 6, 8 was there, and here 1, 4, 10, 18 was there. So this is your cumulative discharge. Okay, simply the area part. Okay. So now what I will get, at first part, obviously the graph will be same. Initially you will see, let me take some another ink here. Okay, initially, sir, what I will see, that graph will be same. Okay, graph will be same up to 1, but when you will reach here, area is 3, but now this graph has to go up. Okay, this graph will go up. This graph, see, at first point it is same, this graph will go up. Okay, now it will go even higher, it will go up to 10. See, it is 6 here, but it is 10 there. At 8 it is 18. So you will see that this will go up as you will progress, as you will move ahead in time. You will see that areas will keep on adding, and more area will keep on adding. You will see that this value will go on increasing. Okay, this value will go on increasing up to here. Okay, up to here you will see that this graph will go up like this till this point. Okay, so this is what, this is your flow mass curve. Okay, this is your flow mass curve. So what is this point representing? See, if I want to understand what this point exactly is, I will say this is what, this point will indicate the this point will indicate the area up to this point. Okay, let me shade it. Okay, the area up to this point, will be indicated by this point. Okay, so this is what, this is indicating area up to that point. This graph is known as, this graph is your flow mass curve. This graph is your flow mass curve, and it is indicating area up to that point T. Okay, area up to that point T. So this is your flow mass curve. Understood, sir? Beautifully, I have understood. So I will write the definition here. What is this? This is a plot of, sir, flow mass curve is a plot of, plot of what? Listen very carefully. Flow mass is a plot of what? Cumulative volume. Okay, if you will find area up to this point, see, you need to understand one thing. In this hydrograph, if you will integrate from 0 to t, okay, if you will integrate from 0 to t, obviously you will get the volume, the total volume which has been passed through a section up to this time t. Yes or no? Let us take an example with the help of which we will be able to understand this clearly. Let us say we have a river. Understood, sir? And this is your section. We are standing here. Okay, let us say we are standing here and observing, and obviously this section will give you certain discharge, because this is your river flow, or let us say a smallest kind of stream. So some discharge will be passing from here every now and then. This discharge is fluctuating also. Sir, tell me, what volume of water will pass through this section? What volume of water will pass through this section in 1 hour? Okay, what volume of water will pass through the section in 2 hours? So if I want to evaluate that thing, what I have to do, I have to integrate this hydrograph from 0 to 1 hour, 0 to 2 hour, like that. Okay, I have to integrate it. I have to integrate my hydrograph from point 1 to point 2 in order to get the total volume of water which is passing through this section, which will be passing through the section. Yes or no? Tell me. So the amount of volume, this point is indicating the amount of volume. This point is indicating the amount of volume which has passed through this section, up to time t. Okay, if you want to find the amount of volume which has passed till here, so obviously now more area will be added. When more area will be added, you will get a higher volume. Yes or no? So this is the logic behind this. So we have understood clearly, sir. We have understood very clearly that it is a plot of cumulative volume. Okay, this is a plot of cumulative volume. You can also call this as cumulative discharge from the start. See, this is important. From the start is important because we will always integrate from the start, from 0. Okay, from 0 to this time, plot the value. From 0 to this time, plot the value. From 0 to this time, plot the value. Okay, take different points, integrate, find the area and plot this area here. Okay, this area will give you actual volume. So it is a plot of cumulative volume from the start versus time, or against the time. So this is the definition of flow mass curve. Basically it is nothing but integration of hydrograph. I will write this point here. It is the integration of hydrograph. It is the integration of your hydrograph. So I hope this point is very clear to you. Okay, so this green line is indicating volume up to time t that has crossed that section. Okay, sir, how much water has crossed this cross section up to time t? That this is answering. Okay, so this line will be indicating, this green curve is indicating volume up to time t. Okay, volume up to time t. So I hope this thing is clear. Yes or no? Tell me. It is indicating volume up to time t. So this is your hydrograph. Okay, so this V is what, sir? This V is what? This V is the volume, or you can say ordinate. Ordinate means the thing which is written on y-axis. Okay, so this green curve is your flow mass curve, and this V will give you the volume up to time t. Simply integrate up to 1 hour, simply integrate up to 2 hour, 3 hour, 4 hour, and so on and so forth. Like this you can integrate and get the volume up to different times. Okay, so this is your ordinate of flow mass curve. Okay, simply change the time, keep different values of time and get the value of ordinate. Okay, the value of ordinate which you have to plot here. So ordinate means the value which we have to plot against x-axis, y-axis. Okay, so this is your ordinate of flow mass curve. So if you want to draw flow mass curve, simply put different values of t here and get different v. So this will give you the v versus t graph, which is shown in this, which is shown with the help of green line. Okay, now sir, why we are finding this? Now the question arises, sir, why we are finding this? Okay, see, we are finding this because it helps in determination of, this point is important because this point has been asked in your engineering services preliminary examination. See, this flow mass curve, listen very carefully. See, this flow mass curve thing, okay, helps in determination of, this flow mass curve thing helps in determination of what? Determination of reservoir capacity. Helps in determination of reservoir capacity. So this is the thing. How come, sir? How come? You should understand that on a river, listen very carefully. See, on a river, okay, on a river, sir, flow was there. Okay, let us say we have a river valley and on that river flow was there. Now imagine we have constructed a reservoir or a dam there. Okay, we have constructed a huge dam there. Try to understand. We have, let us say we have constructed a huge dam here. Okay, let us say we have constructed huge dam here. Then what will happen? You need to understand that in certain amount of time, this water will slowly and steadily build up here. Okay, we have to collect water here, so obviously we have blocked it, so this water will start building up here. Okay, so how much water will be accumulated behind the reservoir? How much water will be accumulated behind the reservoir in time t, that we can easily evaluate, okay, from this equation? Yes or no? This I can easily evaluate, and based on that I can build my dam also. Based on that I can have my reservoir capacity. Okay, so the capacity can be determined with the help of this integration with the help of your flow mass curve. Okay, this flow mass curve will tell you that how big my reservoir should be. Okay, the more the water we want to store, okay, then obviously we will take higher value of T so that more volume accumulates, and obviously the cost for the construction of such kind of dam will be more. Okay, like that. So I hope this thing is clear. So this is your flow mass curve. Yes or no? Yes, perfect. Perfect. So this is your flow mass curve. So this is your flow mass curve. I hope the flow mass curve thing is very, very clear to you. Now we'll move ahead and discuss what stream flow is. Okay, so this was your flow mass curve. Understood. Now we'll discuss the very important topic which you have to start today is your stream flow. Okay, listen very carefully. See, sir, you told me that precipitation is there. Okay, sir. After precipitation, sir, losses are there. Understood, sir. After losses, all the infiltration, evapotranspiration, interception, depression storage, all these things are done. Sir, what will happen? Sir, runoff will be there. Yes, sir. That is also for sure. After runoff, sir, stream flow will be there. Okay. Now guess. I am just asking you a simple question. Tell me which phase of this, see, this is a phase of water cycle. You all should understand this is a part of water cycle. Okay, in water cycle, sometimes precipitation will be there, sometimes losses will be there, sometimes runoff will be there, sometimes stream flow will be there. So these are all different phases of your water cycle. I have a simple question. Tell me, out of all these phases of water cycle, out of all the phases of water cycle, tell me which phase you are going to measure accurately. Tell me. Obviously we have tried to measure precipitation also, we have tried to measure losses also. Okay, we have tried to measure runoff also. There are, I told you, around 6 methods for determination of runoff yesterday only, and we will also measure stream flow in this also. In this chapter we'll discuss about measurement of stream flow. So can you guess, out of all these methods, which method, or you can say which phase we are going to measure most accurately? Can you guess it? So can you guess which phase we can measure most accurately out of all these four? Yes, stream flow is the one. Stream flow is the one. Absolutely correct. Okay, because a small stream has a perfect kind of geometry, and you will see that not geometry, but that you can say that discharge or flow or velocity, that depth will be easily measurable as compared to your precipitation, which is very variable quantity. Losses are also very variable. Runoff is also variable. Runoff happens on land. Okay, runoff happens on land. You need to understand how you can measure runoff. It depends purely on land use pattern. Okay, somewhere forest will be there, somewhere you will see barren land is there, somewhere you will see fallow lands are there. So different cases, in different cases you will find huge difficulty in measuring the runoff. So all these are difficult to measure. Okay, they will not give you the accurate results, but yes, if you will measure stream flow, if you will measure discharge or velocity or depth of stream flow, you will get it most accurately. Okay, so I will write here the very first important point, that stream flow stream flow, okay, stream flow is that phase of water cycle, which can be measured most accurately. Okay, which can be measured most accurately. Okay, sir, now tell me what things we are going to measure. Obviously we'll do measurement of, okay, in this chapter we are going to do measurement of okay, measurement of what? Measurements of, first we'll measure stage, secondly we'll measure velocity. See, this velocity thing is important because this velocity question has been there once in your gate examination, and discharge thing is also little important. This time question from measurement of discharge was there in your gate examination in 2023. Okay, in set 2. Basically in set 2 there was one question which was based on discharge, but yes, obviously this Streamflow chapter is not so important, but yes, obviously we'll discuss it. So first we are going to measure stage. Okay, how we measure stage? What is the meaning of stage? See, stage means the depth. Stage means the depth. The depth of water changes. Okay, gradually with time you should understand, you should appreciate the fact that with passage of time, depth of water changes. Yes or no? Yes. Yes, we can easily calculate dimensions of river and it's just, yes, 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 perfect. Okay, see, these are practical because you should understand the command area. Okay, the things which we have to measure are limited to a very small space. Okay, but if you talk of rainfall, rainfall happens in a very big area. Runoff takes place in a huge area. Okay, so those are different to those are very difficult or cumbersome to evaluate because they that process occurs in a huge area. This is the ultimate fact. Okay, so stream flow basically takes in a confined area, in a limited area. That's why we are that's why the measurement is accurate. Now the first thing we are going to measure stage. Okay, so for measurement of stage you need to understand. Okay, yes, now so for measurement of stage you need to understand, for measurement of stage we have some manual methods and we have some automatic methods. Okay, I will tell both the methods to you all. So the very first one is, for measurement of stage we have the very first one, manual methods. In manual methods, sir, in manual methods, sir, we have two methods. We have staff. See, these are your staffs. Okay, these are your staffs. Okay, so let me write the two types of methods. The two types of methods for measurement of stage are, this is simple. This is simple. The first one is manual methods. Okay, in manual methods you need to understand, again two methods are there. In manual methods, the first method is, this is your staff gauge thing. Okay, we will manually put the staff at different levels of your river. Okay, see, different staffs are required when your river is deep. Okay, when you have moderately deep rivers, then you have to put different staffs and take differential readings. But let us say if we have little, or you can say if we have shallow streams, if we have shallow rivers, then what we'll do, then obviously we'll take only one staff. Okay, and this level of water will give you the mark up to which your depth of water has been there. Okay, so I hope this thing is clear. So this staff is completely gone. That's why we require more staffs. Okay, when level of water will increase, this will also get dipped. Okay, this will also get inside, get submerged into the water, then this staff will work. So we have differential staffs placed so that water reading, the level of water is measured correctly. So this is a staff gauge. Second one is your wire gauge. The second one is your wire gauge. Okay, yes, so what wire gauge is? See, in wire gauge we have a wire which we lower. Okay, we have a wire which is lowered into the stream to measure depth. Okay, imagine you are standing above some bridge. Okay, you are standing above some bridge, and from that bridge you are lowering a wire into the river. Okay, at the bottom you will put some heavy weight such as a stone, or let us say some metal placed at the bottom, so that that wire goes straight inside the river. Okay, or stream. So we, let us say we are lowering a wire here. Let us say we are lowering a wire here and it has touched the bottom. So we will measure the when after that we'll take out the wire. After taking out the wire, we'll see up to which mark it has wet the wire, and till there I will measure the distance or depth. Okay, so this is also one method. This is your wire gauge method. So in wire gauge method I will write one line. Okay, in this method a wire is lowered into the stream to measure depth. Yes or no? And generally the length of wire which you take is not more than 25 meters. Okay, generally the wire is of length of, yes, perfect, generally the length of wire is 25 meters. So I will write here suitable, this method is suitable up to a depth of 25 meters, not more than that. Okay, 25 meters is a you can say sufficient height. So for wire gauge is basically for this one only. Okay, now this is the first method. So this is first one is your manual methods. I hope manual methods are very clear to you. In this we have discussed staff gauge and wire gauge. Okay, here you can see your vertical staff kept here. So these are your staffs, these are your vertical staffs. You must have seen these vertical staffs in survey also. Okay, now we'll move on to the second method, which is your automatic method. See, in this manual methods, obviously you need to understand manpower is required, human resource is required, some skilled man will be required here in order to install the stuff, and a man should be required to lower the wire into the river or stream. So for manual methods we require labor. Now second one is automatic methods. Okay, the second one here is automatic methods. In automatic methods there is no requirement of labor. Okay, there is no requirement of human resource, there is no requirement of person. Okay, good evening SK, good evening Sushil. Okay, great, you have joined the class very quickly. Okay, now we'll discuss automatic methods. See, in automatic methods we have two methods. See, this one is your float gauge recorder. This one is your float gauge recorder. This one is your float gauge recorder, and that one is your bubble gauge. That one is your bubble gauge recorder. Okay, sir, how they measure? Sir, kindly tell me how they measure the depth of water. Bubble gauge recorder. So tell me how bubble gauge and how float gauge they measure stage. Okay, so you need to understand this thing. This is important. Listen very carefully. See, in this you can see this diagram here. Okay, you can see this diagram here. In this diagram you have to understand we have a float. Okay, I hope you can see this float. Okay, I hope you can see this float. Let me color this with some different ink so that it is more clear. I will color it with white only. Okay, yes. So this is your float. This is float, plastic float obviously. See, this float seeks the level of water every time. Okay, this float will seek the level of water. Understood, sir? Understood clearly? So this float will seek the level of water every time. Okay, now we have see this entire assembly. See, we have a pulley. From this pulley we have lowered a float, and in order to keep this wire completely tight we have added a counterweight. So this is your counterweight. Okay, this is counterweight written. See, what is the function of counterweight here? So that the float remains stable. Okay, otherwise what will happen? This float will move here and there. Okay, then second thing, we have this entire assembly, we have closed this entire assembly into a stilling basin. We have a closed chamber. In this we have kept this or installed this assembly. Okay, sir, why? Sir, tell me why you have taken stilling well here. Because you need to understand, this is your stilling well. You need to understand, in your streams or rivers fishes may be there. Okay, wave action is also there. So because of some action of fishes, insects or birds maybe, or let us say waves, because of all these rough actions you will see that this float see, this system can become unstable because of all these factors. Okay, this float this wire can get cut if fishes are there. Okay, or this system will ultimately become unstable if you will keep it open. So that's why I am putting this entire arrangement in a stilling well. Stilling means this well or this cylinder is trying to keep this entire assembly stable. Okay, or is trying to exclude this water from the external effects. Okay, so that it is stable and this system remains here for long time. Understood, sir? Durability has to increase. Now you need to understand that this cylinder will have the level of water as that of outside water. Okay, this cylinder will have the level of water equal to the level of stream. Okay, this cylinder will have the level of water equal to that of stream. Okay, now imagine water will go up. Now imagine water will go up and water can go down also. See, you need to understand this float is constantly at the surface. Now when water will go up, this float will also go up, this counterweight will go down. And when this float will go up, you need to understand, from this pulley a pen is attached. When this pulley will roll, this pen will start moving. When this water will go down, okay, then when this water will go down, float will also go down, pen will start moving in this direction. Okay, pen will start moving in this direction. Pen will start moving in this direction. Okay, this is rolling. Okay, this is your clockwork mechanism. This we have already discussed in your natural siphon part, natural siphon weighing bucket, where we have discussed recording rain gauges. I have told you this thing. Okay, so now when rain gauge float is going down, when water level in the stream is going down, this pen will start moving in this direction. When this float will start moving up, this graph will go in this direction. Like this you will have a graph which will give you continuous variation of the depth of a stream versus time. Yes or no? Sir, this float gauge recorder will give me continuous variation of depth, continuous variation of stage means depth of water versus time. Okay, from this chart I can read okay, at what time the level of water, okay, at what time the level of water was what. Okay, so this we can read out from this graph. Understood, sir? Now the second method. Great. Yes, you all are talking about consistency and inconsistency in the chat box. Okay, obviously no one can beat consistency. Consistency is the ultimate key. Okay, so what I was saying is, now second method is your bubble gauge recorder. What happens in bubble gauge recorder? Sir, in bubble gauge recorder, let us assume the level of water is this. Okay, let us say this is your level of water, and okay, sir, no problem. So let us say this is your level of water. Now we have an instrument room here, we have a laboratory here, just in the vicinity of your stream or river, whatever it is. Now what will happen? We will take down a pipe, we will lower down a pipe up to the bottom of your river or stream. Okay, this is your, let us say this is your river bed, this is your river bed, and up to this point we lower a pipe. Okay, sir, no problem. Now with the help of some pump or something, with the help of some pump or motor, what I will do, I will insert pressure, and from through this pipe I will pressurize air bubbles to come out from here. Okay, so these air bubbles will come out. So these air bubbles which you can see here will come out and will rise to the surface. Now tell me, how much pressure will be required for this air to come out? I hope you all know what is the pressure at height h, at depth h in your fluid. You all must have understood this thing. You all must have read this thing for sure, that pressure at depth h in fluid or in any liquid medium is rho gh. You must have read this thing. So now the pressure can be calculated by you. Pressure is already observed by you, because see, this pressure which is required to bring this air out, the pressure which is required to squeeze this air out at the bottom will be equal to this pressure only. Okay, we'll put, see, this pressure will be read here in the motor, okay, in the instrument room. That pressure we will keep here. Rho we all know 1000 kg per meter cube, g we all know 10 meter per second square approximately. So from this formula we will find the value of h. Okay, so this is a different kind of setup. Okay, so bubble gauge will require some pressure in order to ooze out air bubbles, and that pressure will put in this equation in order to find the h value. So is this thing clear? Tell me, is this thing clear? So with the help of this pressure I will find the height. Okay, so this is your, these are your automatic methods. Okay, so we have discussed measurement of stage, we have discussed staff gauge, we have discussed wire gauge, we have discussed your automatic methods. Okay, in this we have discussed float gauge, and this we have discussed your bubble gauge recorder. So these were your measurement of stage. Now we'll discuss, okay, now we'll move ahead, and now we'll discuss measurement of velocity. Okay, so measurement of velocity is another important concept. We have current meter. Current meter is one of the important topics of your hydrology. Okay, current meter is also known as price meter. You can see this is your current meter. See, we have two kinds of current meter basically. Okay, we have two kinds of current meter basically. We have a vertical current meter and we have horizontal current meter. See, in this one, see, try to look at this assembly. Basically, we will discuss about two types of current meters. Current meter is used for measurement of velocity. Okay. Yes, sir. Current meter. Current meter is also known as price meter. Current meter is also known as price meter, which is used which is used which is used to measure velocity. Okay, sir, no problem. Which is used to measure velocity. How, sir? Tell me. See, firstly, you need to understand these are of two types. Okay, these are of two types. The first one is a horizontal one. Okay, see, in this horizontal, see, this is our vertical current meter. Basically, this is my vertical current meter. How, sir? Tell me how this is vertical, which is horizontal. This is your vertical price meter or vertical current meter, and this one is your horizontal current meter. This is your horizontal current meter. Understood, sir? See, what is the principle or mechanism with the help of which your current meter works? Now, what I will do, I will, you can say, I will submerge this assembly into the stream. Okay, this complete assembly will be going down into the water. Okay, this complete assembly will be going down into the water. Okay, sir, no problem. Now, after going down into the water, you need to understand water will be flowing. Water will be continuously flowing. So that flow of water will, what it will do, see, this is your axis around which see, we have 6 cups here on vertical axis. See, this is cup assembly. We have basically 6 cups. Okay, basically we have 6 cups here, and these cups will start revolving. Okay, you must have seen at the top of some buildings, you must have seen some wind vane. So that wind vanes rotate. That wind vane rotates when you can see when optimum kind of wind velocity is there. You will see that wind vane rotates. So in a similar fashion, what I will see, when this water will start to flow, when this water will start flowing, these 6 cups which are placed here, okay, this cup assembly will start rotating. This cup assembly will start rotating, and you should appreciate the fact that faster the velocity of your water, then obviously these cups will rotate in a, you can say, more speedy manner. The rotational speed, the number of revolutions per second will be more if your water is faster. Okay, so I hope this thing is clear. Understood, sir? No problem. This is also clear. So what you are saying basically is, this is, in this we have vertical axis around which this assembly is rotating. Okay, so this is your vertical axis. About vertical axis your cups are rotating. Okay, due to the flowing water. Understood? But here in horizontal current meter, you need to understand this meter. In this meter, we have a blade here. You can see this blade. Can you see this blade? See, when this current meter will move across the river, see, let us say we have submerged this entire assembly into the water. Now what will happen? Because of the flowing water, what will you see? You will see that this fan, this blade will start rotating. This blade will start rotating. Now when it will rotate about horizontal axis. Yes or no? Tell me. This blade will rotate. See, the faster the rotation of this blade, that will imply that the river water or stream water is even faster. Yes or no? The rotational speed of this blade, the rotational speed of current meter will indicate how fast the water in your river is. Yes or no? So in this one, about horizontal axis rotation is there. In this one, about horizontal axis rotation is there. Okay, sir. Understood. In this one, about horizontal axis rotation will be there. So this is your horizontal current meter. Why? Because, sir, axis is horizontal. Sir, why? Because axis is horizontal. Okay, so we have basically two kinds of current meter. But one thing is for sure, we need to understand one thing, that velocity is proportional to n. Meaning, this rotational speed, see, the rotational speed of this thing. Okay, listen very carefully. We have to understand one thing. Here, that rotational speed rotational speed of current meter, rotational speed of current meter is proportional to the velocity of water. Yes or no? The faster the faster moving water is there, you will see rotational speed of your current meter is more. Yes or no? So higher the stream velocity, higher will be the rotational speed of your current meter. Okay, so this is the important phenomena. You need to understand velocity of your, sorry, velocity of your, I've written it in reverse fashion. Basically, we should write stream velocity is proportional to stream velocity, or velocity of your river or stream is proportional to rotational speed. Okay, so V is proportional to N. So we can say that V is proportional to N. This is the entire concept here. Okay, I hope this thing is very, very clear to you. Now I will write the theory part here. So current meter I have already told you. Current meter I have already told you, it measures velocity at any depth. Okay, it is used to measure velocity at any depth at any given section. Okay, let us say you are this is your river flowing, you are here, and in this section you can go up to any depth, and find the velocity with the help of this current meter. Okay, so basically it is of two types. It is of two types. The first one is vertical axis. It is of two types. Sir, it is of two types. The first one is vertical axis current meter. The first one is vertical axis current meter. The second one is horizontal axis current meter. The second one is horizontal axis current meter. Okay, so we have vertical one, we have horizontal one. Now we have a sounding weight at the bottom. Okay, see, in this current meter we have certain things. In this current meter we have certain attachments. Okay, let us see here. See, this is your sounding weight. Okay, at the bottom you can see we have a weight here. See, why this weight is here? You need to understand, when you will lower the current meter into the river, what will happen? This sounding weight will stabilize the current meter. Okay, see, if this weight was not there, then what we'll see, that this entire hoist, okay, will disbalance. So because of this weight, this vertical assembly will remain in a straight line, and it will be stable. Okay, so we have a stabilizing fin also here, we have a sounding weight also here, so that this entire assembly remains stable and it is not affected by your shock waves or something. So I will write what is sounding weight. So sounding weight basically stabilizes. Okay, sir, sounding weight basically what it does, sir, it stabilizes. Sounding weight basically stabilizes or balances. It stabilizes or balances the weight of, it stabilizes or balances the weight of current meter. Okay, weight of current meter. And how much weight we should attach here, how much weight we should connect here, the formula for that is given by W equals 50 V average into D. The meaning of this is W means sounding weight, and this weight will be obviously in newtons. Yes or no? This weight will be obviously in newtons. What is V dash? V dash is average velocity. V dash is average velocity of your stream. What is D? D is depth of water. D is depth of water. So more the depth, more is the weight which you should attach. Otherwise it will get unstable. So more the depth of water, more should be the weight. More the depth, more the weight. Okay, so this is a simple concept. So I hope this sounding weight concept is clear to you. Okay, now sir, you have told me that stream velocity is proportional to rotational speed. This is for sure. Okay, this is simple. Now we have one formula. If we will apply constants here, I will see this final relationship. V equals AN plus B. Okay, this is the ultimate relationship which you have to remember. V is equal to AN plus B. Obviously V is proportional to N, and when I will add constants, we have two constants known as A and B. Okay, now how I will calculate this A and B? Okay, how I will calculate this A and B? So for calculation of A and B, I have to do calibration. What I have to do? Sir, I have to do calibration. The meaning of calibration is that I have to find these constants. Sir, once I know these constants, I will put these values here and simply put the value of n in order to evaluate or compute or simply find the value of your stream flow. Okay, velocity of stream flow. Okay, let us say you are, let us say you know the value of A and B. Just suppose you know the value of A and B. Suppose it. Okay. Okay, sir. I suppose that I know the value of A and B. Hello, dear. Hello, dear. How are you? Okay, so what I am saying here is, let us suppose we know the value of A and B. Now, and I have lowered down the current meter into the stream. Let us say this is a stream, and we have lowered down the entire assembly of current meter into the stream. Okay, current meter, let us say we have gone 2 meters deep, and when we have gone 2 meters deep, there current meter has rotated 50 revolutions in 1 minute. In 1 minute. 1 minute means 60 seconds. So the value of n will be how many revolutions? Sir, 50 rotations in every 60 seconds. Okay. So this is the rotational speed n. When you will put the value of n, you know A, you know B already. Simply by putting the value of n, what you will obtain? Simply by putting the value of n, you will get the velocity of stream. Yes or no? Tell me. But first, you have to know the value of A and B. Yes or no? But first, you have to know the value of A and B. This is important. So, now sir, tell me how I will find the value of A and B. How I will find the value of A and B. So, for finding out the value of A and B, we have an instrument known as towing tank. Okay. See, calibration means we have to find these constants A and B. We have to calibrate current meter. And find a relationship between V and N. We have to find a relationship between V and N. Okay, sir. So this is done with the help of, this calibration is done with help of towing tank. Okay, sir, what is the meaning of towing tank? I will explain, don't worry. With the help of towing tank, which okay, which gives some values of, which gives some values for n, corresponding to V, which helps in finding constant A and B. Okay, sir, how? Tell me. See, towing tank in an instrument with the help of which you can pull current meter. Okay, so let us say this is your towing tank, and this water is permanently still. In this water we have no velocity. That water is still. Still water means it is not flowing. This water is not flowing. Yes or no? So you need to understand. Let us say this is your towing tank. Okay, try to comment, everyone. Now with this towing tank, I have attached current meter. Okay, with this towing tank, sir, I have attached current meter. Now I have attached current meter, and obviously you need to understand, when this towing tank will move, listen very carefully. Okay, obviously this current meter will be lowered into the water. Now let us say we have moved this this towing tank. Towing tank means it's a kind of tractor thing. Okay, it is pulling the current meter. Let us say we have pulled this towing tank at a speed of 5 meter per second, and when we have pulled it at the speed of 5 meter per second, then let us say the number of rotations in the current meter is, let us say 40 revolutions per minute. Okay, in 1 minute I will, with the help of my stopwatch, I will count it, and then I will change the speed. Now let us say I've just doubled the speed. Let us say I will just double the speed, but I have found the value of, obviously now when the towing tank will move faster, the number of rotations, the rotational speed or number of revolutions will increase obviously. Okay, let us say it has gone to 70 per minute. Let us say it has gone to 70, or let us say 90, like that. Okay, so let us say it has gone to 90. So when velocity is 5, n is 40. When velocity is 10, n is 90. You will use this equation. You will put the value of v and n. Again, you will put the value of v and n. You will get two equations. Solve it simultaneously and you will get the value of a and b. Solve that equation simultaneously and you will get the value of a and b. Yes or no? Have you understood this thing? So with the help of towing tank, you will drive that towing tank. You will obtain certain speeds, and corresponding to those speeds you will find the rotational speed. You will count the rotational speed, you will observe it. With this data, okay, see, this towing tank will give you some values for n corresponding to different velocities, which will help me in finding constants a and b simply by using this equation. So I hope this thing is very clear to you. So is this thing clear? Kindly write yes in the comment box. Is this thing clear? How with the help of towing tank we do calibration? Calibration simply means that for my current meter, I know this relationship. I know the value of a and b. Okay, after calibration, I know the value of a and b. When you will purchase current meter from the market, what you will observe, the value of a and b are given to you, because that current meter would have already been calibrated with the help of towing tank. Okay, is this thing clear? Kindly write yes. So with the help of towing tank you will find. So I will give you some example. Okay, let me give you some example with the help of which we'll understand how this towing tank thing works. And after we have found out the constants, a and b, simply put the value of n and get velocity. Okay, your current meter will give you rotational speed. Simply put that rotational speed and find the velocity. This is one of the best methods in order to find velocity at any depth, at any section. Okay, so is this thing clear? Everyone kindly comment yes or no. Have you understood this thing? Okay, so now we are going to solve a question. I hope this concept is very clear to you. So whatever concept I have told you there, I will apply it here in this question. Okay, I will apply that concept in this question. See, this is a great question and it is also a previous year from GATE. This question has been asked once in GATE examination. Okay, we'll try to understand this. Yes, perfect. Listen very carefully here. So the question is saying the number of revolutions of a current meter in 50 seconds, okay, were found to be 12 and 30, corresponding to the velocities of 0.25 and 0.46 meter per second respectively. See, these two lines, listen very carefully, these two lines are giving you the data. For towing tank. Okay, let us say we have a towing tank. Okay sir, and we are moving that towing tank at a speed of 0.25. Let us say we are moving it at a speed of 0.25 meter per second. Sir, when I am moving it at a speed of 0.25 meter per second, then the number of revolutions my current meter was taking, the number of revolutions which my current meter was taking is 12, and that too in 50 seconds. In 50 seconds, I have only 50 seconds time. So I started my stopwatch. From my stopwatch, I just counted for 50 seconds, and in 50 seconds, the number of revolutions is 12 only. Corresponding to this velocity. Is this thing clear? Now the second reading, now my towing tank was moving. Now the towing tank was moving at a speed of 0.46 meter per second. Obviously you can see the speed has increased. Okay, so when this speed was there, in that case, when towing tank was moving at 0.46 meter per second, the number of revolutions were 30. Okay, again in 50 seconds, this number of revolutions were again in 50 seconds. The time period I had made constant here. Okay, The time period I have made constant here. So now I have to find first. Now their question is saying what velocity would be indicated by 50 revolutions of that current meter in 1 minute. So if I want to find the velocity, first I have to find the equation. Without finding A and B, how I will find velocity? First, the responsibility is I have to find A and B. Then I will put the value of n, which they are saying, and then I will obtain the velocity, because the question is asking you velocity. But for that, we have to do calibration first. With the help of towing tank, I will find the velocity. I will find the constants A and B, and then I will move ahead and find my velocity. Okay, sir. Tell me how I will do this. So you all know the relationship is V equals A n plus B. Understood, sir? Relationship is V equals A n plus B. Now, if V equals A n plus B, then I will use these values. Okay. First equation will be velocity is 0.25. A is A. N is how much? 12 revolutions in 50 seconds. Rotational speed is what? 12 by 50. Okay. I will not write N here. This is 12 revolutions in 50 seconds. This is 30 revolutions in 50 seconds. So I will write the value of N is 12 rotations in every 50 seconds. Number of rotations per second plus B. So this is your first equation. Now the second equation will be velocity is 0.46. Velocity is 0.46. Okay. N value is 30 upon 50. N value is 30 upon 50 plus B. This is second equation. Now I have to simply simultaneously solve them. I will simply solve them. See, subtract this. When you subtract 1 from 2, B and B will get cancelled. This will be 18 by 50 and this will be your 0.21. So 0.21 divided by 18 into 50, you will get the value of A. Okay. So this is simple. You can solve it. Let me solve it in calculators. Let me see what we are getting here. Okay, let me see what we are getting here. When you will solve these two simultaneous equations, we will get, okay, solve for A and B. Solve for A and B. Okay, solve for A and B. So from this one, what I will do, I will simply calculate the value of A here. When you will subtract, B and B will get cancelled. This will give you A as 0.5833. Okay, now A you have got. Simply put this value of A in this equation here and simply find the value of B. When you will put A as 0.5833, okay, multiplied by 12 by 50, subtract it in 0.25, you will get the value of B, which is coming out as B is coming out to be 0.11. B is coming out to 0. So my final equation is, so the final equation which basically governs the entire relationship, the final equation will be V is equal to what is the value of A? What is the value of A? Sir, A is 0.5833. Yes or no? We have found out the A. A is what? 0.5833. 0.5833 N plus what is B? 0.11. What is B? 0.11. Okay. So we have found out the relationship. Now the question is saying what velocity would be indicated by 50 revolutions of that current meter in 1 minute. Okay. Now N is given as, tell me. N is given as we have to find velocity. So I will put V equal to 0.5833 multiplied by N. N is what? N is 50 revolutions. N is what? Sir, N is 50 revolutions in 1 minute. 1 minute means 60 seconds. See, in every case, the value of N which we have written here is N is in revolution per second. N is in revolution per second. How many revolutions my current meter is taking in 1 second? Okay, so we have to divide by second only. Okay, the time unit which we are taking here is second. Okay, so tell me what velocity we are getting here. Everyone kindly comment. Plus 0.11. What velocity of stream we are getting here at this condition? Tell me what we are getting here. Kindly comment, everyone. Kindly comment. Yes, so what we are getting here is, we are getting here 0.11 0.6 meter per second. When you will solve, you will get it as 0.6 meter per second. Okay, so this is the solution to your gate question. I hope it is very, very clear to you. Okay, tell me, is this thing clear? Tell me, is this thing clear? Everyone kindly comment in the comment box so that I'm able to understand that you have understood this beautifully. So I hope this concept is clear to you. Everyone kindly comment yes. Then we'll discuss the field use formula. Then we'll discuss the clear. Perfect. Perfect. Now we'll discuss the field use formula. So this is the instrument. This is an instrument, current meter, price meter, which is used to measure your velocity, which is used to measure a velocity part. Now we'll discuss some field use formulas. So I hope you are ready for field use formula. Wait a second. Yes. Now we'll discuss the field use formula. So the very first, you need to understand one thing. Before starting field use formula, let me give you the understanding behind it. Okay, so this is your, let us say this is your depth of river. Okay, let us say this is your depth of river. Okay, this is your depth of river. You need to understand this is your depth of river. Okay, so can you tell me the value of velocity, will it be same at every depth? Value of velocity, will it be same at every depth? The answer is no. The velocity will be different. Okay, the velocity will be different at different depths. Listen very carefully here. The velocity will be different. The velocity will be different at different depths. Okay, so on this x-axis, I have written velocity. On this x-axis, I have written velocity. And on this y-axis, I have written depth. Okay, this is your depth. This is basically your logarithmic kind of curve. Okay, so this is your velocity. This is your velocity. So velocity is less at the bottom. It will increase as your depth is increasing. See, this is your channel bed. As you go far away from bed to the surface, you will see that velocity is increasing. This is your maximum velocity, and at the surface we have little less velocity. Okay, so this is your surface velocity. Surface velocity will be indicated by Vs. Okay, what is the meaning of Vs? Vs means surface velocity. This is your Vmax. You can see this velocity is maximum. Velocity is maximum here. Okay, this is what? This is your Vmax. So maximum velocity occurs, you can say, little under or just under the surface. At surface we don't have maximum velocity. Okay, we have maximum velocity just below the surface. This is generally for open channels. Okay, for any kind of streams, for any kind of open channels, you will generally witness this kind of velocity distribution. So this is basically your velocity distribution curve. This is basically your velocity distribution with respect to depth. Is this clear, SK? This is your velocity distribution with respect to curve. Yes, perfect. Great. Can you tell me, SK, can you tell me what is the shape of this curve? Is this parabolic, elliptical, hyperbolic, or logarithmic, exponential? Like this, can you tell me what is the shape of this? Can you guess it? What is the shape of this curve? Try to guess it. Okay, till then I will write here. See, velocity distribution is, first you tell me, then I will write here. First you tell me. Let me see if you are able to answer it clearly. You don't know it, I think. I think you don't know it. You are saying it parabolic. No, wrong. Velocity distribution profile is logarithmic. Okay, it is logarithmic. Okay, this you can learn. So in open channels, basically you will see for any kind of stream or river, you will see the velocity profile is generally logarithmic in nature. Okay, now we'll understand different formulas. Now we'll understand different formulas for average velocity. Now we'll understand different formulas for average velocity. Okay, listen very carefully. Okay, so different formulas for average velocity will be, the very first one is average velocity will be equal to v.6. Average velocity will be equal to v.6. Now this average velocity is equal to v.6 only for shallow streams. Okay, this formula is valid for shallow streams whose depth is even less than 3 meter, which are very less deep, or you can say those are shallow, which are shallow. So this formula is valid for your shallow streams. Now sir, what is the, see, average velocity is equal to v.6. What is the meaning of v.6? Okay, what is the meaning of v.6? See, v.6 means, listen very carefully, assume this total depth equal to y. Assume this total depth equal to y. Now v.6 means you will find velocity at 0.6 times the depth. Okay, 0.6 times the depth means what? 0.6 times the depth means what? You will go 0.6 times. Okay, let us say this is your 0.6. This is 0.5, this is 0.6. Yes. The velocity here will be termed as v.6 when you are going 0.6 y deep from the surface. From surface, how much distance you have to travel? 0.6 times y, where y is what? Y is the total depth. When you will go 0.6 times y, 0.6 times the total depth of your water, there you measure the velocity. That velocity is known as v.6. So you will lower the current meter up to this depth and measure the velocity here. So whatever velocity we have, that will be your average velocity. That will be considered as average velocity. Yes or no? Okay, so velocity measured at 0.6 times the total depth. The velocity measured at 0.6 times the total depth is known as v.6. Okay, so I hope you can calculate what v.6 is. Okay, then we have 2-point method. Okay, then we have 2-point method. So v average is v.2 plus v.8 plus v.8 upon 2. Okay, this is for moderately deeper streams. This is for moderately deeper streams. If you have streams which are more deep than 3 meters, then I will use this formula. Now what is the meaning of v.2, v.8? Obviously sir, same. Sir, I will go 0.2 times the total depth. Okay, how low I will go? I will go 0.2 times the total depth. Here I will measure the velocity. This velocity will be v.2. Okay, then I will go 0.8 times the total depth. 0.8 times the total depth. Okay, here I will measure the velocity, which will be equal to v.8. So I will measure velocity at two different points. First I will go 0.2 times the total depth. Then secondly, I will go how much deep? 0.8 times the total depth from the free surface. Okay, I will put these values here. I will put these two velocities here and simply find the average. This will give me average velocity. Okay, see, let me write the meaning of all these things. v.2, what is this? Sir, v.2 comma 0.6 comma 0.8 means velocity at 0.2, 0.6 or 0.8 times the total depth. Okay, I will measure the velocity at 0.2 times the total depth. This is your velocity at 0.6 times the total depth. v.8 velocity at 0.8 times the total depth. Yes or no? Is this thing clear? This is v.2, v.6, v.8. Now the third thing and the last formula for average velocity is k times surface velocity. See, this Vs is surface velocity. Yes or no? This Vs is surface velocity. Okay, let me write here. This Vs is surface velocity. Okay, understood. What this K is? See, K is a reduction factor. K is a reduction factor. K is a reduction factor. Generally, its value is somewhere between 0.85 to 0.95. I will write here 0.85 to 0.95. Okay, I hope it is in your screen. Yes. Great. Okay, first of all, namaste to Nani. See, I'm using okay again and again because I want you all to understand clearly. So that's why, for giving more emphasis, I'm saying okay and okay again. So what I was saying here is that K was reduction factor. So K was reduction factor, which is varying from 0.85 to 95. So I hope this thing is clear now. So we have average velocity formula K into Vs. But how I will measure surface velocity? The thing is, how I measure surface velocity. See, for measuring surface velocity, what I will do, this is your stream. Let us say this is your stream. Okay, you are seeing it from the top. Now you have, this is a piece of float. Okay, float is a plastic thing which generally remains on the water surface only. It will not sink. Okay, so float remains on the top surface only. So what I will do, I will take two sections. This is, let us say, this is your section 1, this is your section 2. Okay, this is section 1, this is section 2. Listen very carefully. And let us say your float has traveled distance L, and you will use a stopwatch to measure the time. You will use a stopwatch to measure the time. Okay, your stopwatch will be started when this float will, you can say, cross section 1, and once it reaches section 2, you will stop the stopwatch. Okay, you will stop the watch. Now what will happen, you will read the time, and obviously the velocity will be measured. Velocity is none other than distance upon time. You should understand the fact that this float has taken time t in traveling distance L. So you will divide the distance L by t in order to get the surface velocity. Since your velocity is floating over the surface, you will get the surface velocity. Put this surface velocity here. Multiplied by reduction factor 0.85 or 0.95 or 0.9, whatever it is, you will get the average velocity. Okay, so I hope this thing is clear now. So this is how you measure. Average velocities. Now, sir, the question arises, sir, why you have told me these three formulas for finding average velocity? Now I want to know why we are calculating this average velocity. Yes, you are right. We are calculating average velocity. Average velocity formula is different for different conditions. Okay, if you have surface velocity, you will use this formula. If you have moderately deeper streams, then this formula will be suitable. But in this, see, deeper streams will have, you can say, will have too much of difference in upper depth and lower depth. Okay, when you will be near the surface, velocity will be too different as compared to your velocity which is at lower depths. Okay, when you have deeper streams, then velocity will be different. This will vary by too much. Okay, this will vary by great amount. So obviously I will require velocity at 2 points. So that I get better answer. But when you have shallow streams, you can go in somewhere in the midsection. Such as 0.6 times the total depth, and you will simply measure the velocity. That will give you the average velocity. Okay, so average velocity is a kind of velocity. Wait a second, sir. Average velocity is a kind of velocity. Let me draw a line here. Okay, with the help of which. Okay, so average velocity is a kind of velocity which is. So average velocity remains constant throughout the section. We have assumed average velocity. Wait a second. So this is your V average. So V average means we have constant velocity. Throughout the section. So if I want to replace my velocity distribution, this actual velocity distribution with some average kind of velocity distribution, I will use V average here. Okay, so you need to understand the discharge which will pass through this actual velocity distribution and the discharge which will pass through this average velocity distribution will be same. Okay, this is the concept behind. Now, how I will find discharge? How I will find discharge? Obviously, sir, I will find discharge using formula area into average velocity. That's why I'm interested in this field formulas. Okay, discharge will be area into velocity. So in order to find the discharge, through your stream section or river section, I will find this average velocity. Okay, so one question has been asked in gate examination. They were saying, okay, according to that question, find the discharge through a section. Everyone quickly solve this question. It's a very simple question. So this question is saying, find the discharge through a section. Find the discharge through a section. Find the discharge through a section. Velocity at 0.2 times the depth. Velocity at 0.2 times. Velocity at 0.2 times the depth is 0.4 meter per second, and velocity at 0.8 times, the depth is 0.6 meter per second. Okay, and this is your triangular cross section. The top width is 4 meter, and this is 1 meter. So find the discharge through this one. Okay, find the discharge through this one. So I'm giving you 1 minute's time. With the help of this data, you can simply find the discharge through this triangular section. Find it. It's very simple. Find the discharge through this cross section. So it will be equal to, tell me what discharge you are getting here. What discharge you are getting? So if you want to find discharge, first we have to find the velocity. We will use 2-point method here. Okay, by 2-point method. See, 2-point method means first I will go at depth of 0.2 times. Then secondly, I will go at the depth of 0.8 times. Yes or no? This is 0.2 times the total depth. This is 0.8 times the total depth. And there the velocities we have measured, which is given to me in the question. So how much we are given? By 2-point method, average velocity will be v.2 plus v.8 divided by 2. Okay, this is your average velocity, v.2 plus v.8 divided by 2. So how I will find this? v.8 is given to me as v.2 is given to me as 0.4 meter per second. This is 0.4 meter per second. This is 0.6 meter per second. You can see here. Simply find the average velocity. Average velocity will be coming out to be 0.5. Okay, this is coming out to be 0.5 meter per second. Simple. So how you will find discharge? Discharge is none other than area into average velocity. Now what is the area of this triangle? The area of this triangle will be half into, yes, perfect, area will be half into base into height. Find the area of this triangle, half into base into height. Yes, V is 0.5. Base is 4. Half into 4. Half into 4 into height is 1. So this is your area. This is your area thing. Multiplied by average velocity, which is 0. Multiplied by average velocity, which is 0.5. So you will get it somewhere around 2 into 0.5 is 1. 1 meter cube per second. See, this is in meter per second and this is in meter square. Area is in meter square. Meter square multiplied by meter per second is meter cube per second. So this is the value for discharge. Perfect. 6. No. It is not 6. It is coming out to be, yes, 1. 2 multiplied by 0.5 will be 1. So this is your, I hope now it is clear. Okay, perfect. Yes, obviously you should go for this. Okay, you should obviously go for your state examinations, that it for sure. Yes, you should obviously attempt for state examinations, because obviously when you will crack it, you will get job near your home, obviously. So you should obviously attempt it, no matter what, be it descriptive or objective. Pattern changes with time, but you have to see, if syllabus is changing, it is changing for everyone. Okay, you are not special. If syllabus is changing, that difficulty will be faced by everyone. Okay, so no need to worry about it. Now we'll discuss the measurement of discharge. Obviously this will start tomorrow, but let's have a quick introduction about it. Okay, so that it is easier tomorrow. Now, for measurement of discharge, we have different methods. Some methods are direct methods. Some methods are direct methods which is performed directly on your stream. Okay, so the very first one is your area velocity method. See, in GATE 2023, a question has been asked directly from area velocity method. Direct question. So this formula is important now. See, this measurement of discharge topic is not so important, but since this time they have tried to surprise you, IIT Kanpur, that's why we have seen question from here also. So area velocity method, then we have moving board method, then we have dilution, then we have dilution technique. Okay, dilution technique is there. Then we have electromagnetic method. I will give you idea about each and every method tomorrow itself, but first let me tell you the name of these methods. See, the name of these methods are important for the state examinations. Okay, in state examinations or in engineering services prelims, only names can be asked. So electromagnetic method is there, ultrasonic method is there. These are different kinds of method which are suitable in different conditions. Okay, for different site conditions, for different existing conditions, you will find that different methods will be suitable. So these are some direct methods. Out of these direct methods, area velocity and dilution technique are important, but obviously the overall topic is not so important. But if we have to choose which two are most important here, I will say these two are more important. Okay, now some indirect methods are also there. Some indirect methods are also there. Okay, sir, tell me those methods. Tell me those indirect methods. So these are direct. These are indirect. Okay, so in indirect we have some flow measuring structures such as weirs and notches. You must have heard about weirs and notches in fluid mechanics. We have certain kind of broad crested weir, okay, sharp crested weirs are there. So different kind of weirs are there. With the help of uh, stage discharge, or you can say the head and discharge relationship, you can simply find the discharge, okay, directly. So these are flow measuring structures. These are flow measuring structures. At control points, at control point, we construct these devices, or we construct these structures, okay. When water passes through here, when water passes through these structures, automatically you will get the discharge, you will get the volume, okay. These are flow measuring structures such as weirs, flumes, etc. Such as weirs, flumes, etc. Secondly, we have slope area method. From slope area method, one question has been asked in your mains examination once in engineering services. From slope area method, so we'll discuss one question of slope area method tomorrow, okay. So these are all the methods with the help of which you can measure discharge. From here, according to me, this and this you should focus, okay. You should focus on this one only, and other methods are not so important, okay. Weirs and flumes will also discuss in irrigation also. So this will be the end of today's lecture, okay. So I hope you have enjoyed it. Wait a second. Yes, so I hope you have liked the session. We'll end it today. We'll end it here. Today we will end it here, and tomorrow we'll catch up with measurement of discharge. After that, we'll start your hydrograph. Hydrograph is one of the most important topics or chapters, okay. And one thing, now we'll catch up on Monday, okay. Obviously Friday is here, so tomorrow, Saturday, Sunday will not be any classes. And one more thing, one more announcement is there. From 20th of March, those who want to study, uh, mathematics, okay, those who want to study mathematics can join batches. You can check the schedule of these batches on PW app itself, okay. So there you can, fresh batches are starting from 20th March, Shresht 2.0, in morning and in evening also. So you can join that batches, and from 20th, Vijay batch is also starting, which is for droppers, okay. So I hope you have liked the session. We'll catch up on Monday with new topics, okay. So thank you everyone, stay blessed, take care, good night.